We're going to review derivatives a little bit in this video and kind of go through some of the basics from our first chapter on this. So we know that derivatives have a couple of notations now. We can refer to the derivative as f prime of x. We can refer to the derivative as dy dx. Or sometimes we just simply call it y prime. And really, to be honest, all three of these things mean the same thing. So if you call the derivative f prime, y prime, dy dx, they're all similar notation. It's just different ways of writing the same thing. And so we have some different ways of doing this. The first way that we've learned how to do derivatives was the traditional way. The way that we first learned is called the limit process. And the limit process is the foundation. It's where derivatives begin with, but it's long. And after a while they get pretty difficult. So the limit process is great. It's based on this formula, f prime of x equals the limit as h goes to 0, f of x plus h minus f of x all over h. And there's some other videos posted on how to do this, but we're kind of trying to get away from it. We're trying to say, okay, we know the limit process, we understand the concept, we can do the limit process, but we don't always need it. We can use some shortcuts. So that's what we're really looking for, is some shortcuts. And the shortcuts I'm talking about are the ones that come from patterns that we find with our answers. So there's 3 in class that we're working real heavily on right now. Number 1 is the good old power rule. We really want to have the power rule down. Number 2 is our product rule. So product rule. And number 3 is our quotient rule. Quotient rule. If you can really get the power rule, the product rule, and the quotient rule down, calculus will be easier for you because we're going to use these continuously throughout the whole school year. They never go away. You're always power ruling things. You're always using the product rule. We're going to make things more complicated as the year goes on. But if you don't understand how to do these really, really quickly and easily, like it's no big deal, you'll have kind of a hard time. So we're going to spend this video kind of reviewing over these 3 topics, basically. So let's start with an example. And for our first example, let's review a little bit of power rule. So let's say you had y equals 5 over x squared, and you want the derivative. You could do this fun limit process up top here in red, but we're trying to use shortcuts. So I'm going to rewrite this. I'm going to say this is really y equals 5x to the negative 2 power. And this is a perfect power rule setup. Now, the power rule looks like this. Anytime you have something to a power, so anytime you have y equals x to a power, like in this case we have negative 2, but it could be any number, so I'm going to call it x to the a power. The rule is the derivative, y prime, is found by taking the power and multiplying it down, taking a and doing a times x, and then taking the power a and subtracting 1 from it. That's the power rule. So we're going to apply that to this problem. We're going to take the power of negative 2 and bring it down and do negative 2 times 5x. And this whole thing will equal our derivative, y prime. And then we're going to take negative 2 and subtract 1 from the power. So I get negative 2 times 5 is negative 10, x to the negative 3 power. And technically this is our answer. If we don't really like negative powers, we try and put them back in the bottom of the fraction so they're positive. So y prime equals negative 10 over x to the 3rd power. And that's my answer. I can leave it like that. So that's kind of my power rule. That's basically what it looks like. So one more, and then we'll move on to the product rule. One more example here. Imagine you have a different setup. You have f of x equals. So f of x equals, and you get this thing. You get the square root of x plus 3x squared plus 4x plus 8. I don't know, some long thing with a bunch of little parts to it. You can power rule every piece of this problem. So what I'm going to do is I'm going to rewrite it once. F of x equals. I want everything to look like that x to a power. So right here, radical x, I'm going to make it x to the 1/2 power. It's the same thing. Plus 3x squared plus 4x plus 8. And if it helps you, really this is 4x to the 1st power, if you need that up there. So my derivative, f prime of x, is going to equal, multiply each of these powers down. So 1/2 times x to the 1/2 power minus 1, plus multiply the 2 down, 2 times 3x squared minus 1 from the power, plus multiply the 1 down, 1 times 4x to the 1 power minus 1. Now the 8, how are we going to take care of the 8? Well, you could think of it as x to the 0 and multiply 0 down, but you know when you multiply 0 down, you're going to get 0. So the derivative of just a regular number always ends up being 0 because of that reason. So we have f prime of x equals, we have 1/2 x, and then 1/2 minus 1 is a negative 1/2 power, plus we have 2 times 3 is 6x to the 1 power, plus 1 times 4 is 4, and then we have x to the 0 power, plus 0, plus nothing on the end here. So to clean all this up, one more step, f prime of x equals, I don't want a negative power, so I'm going to move that down. I'm going to make it 1 over 2, because of the 1/2, and then x to the positive 1/2 power, plus 6x, I don't need to write the little first anymore, plus 4x to the 0, x to the 0 is technically a 1, so that's gone, so it's really just plus 4, and I don't even need the plus 0, so that's my answer. So that's basically how the power rule works. It's a really shortened version of, there's a lot of problems out there that use this, but just to give you kind of an idea to review with, you should be comfortable with this and know how to do these types of problems. Here's what the product and the quotient rule look like. So new example. Let's say I gave you w of x equals quantity x squared plus 4 times x to the 5th plus 7x. And I want the derivative. Well, the common mistake on this problem is people start power ruling all the pieces because you get so used to the power rule and it's like, oh, I'll just make this 2 times x and 5 times x, and you're going to get the wrong answer if you do that. Instead, because you're multiplying two quantities, it's like a time symbol here, we have to use another rule. We have to use this thing called the product rule. And we have a way of kind of memorizing this. In class, I make you chant this out and get it stuck in your head. But it's the first, here's the first, times the derivative of the second, plus the second times the derivative of the first. So I kind of go through that in my head, and I basically write all that out. So let's go through it a little bit here. W prime of x equals the first times the derivative of the second. So the first is x squared plus 4, and the derivative of the second I can power rule. So 5x is going to be, it's going to be 5x to the 4th, plus 7x turns into just being a 7. And there's my first times the derivative of the second. Then I got to do plus the second. So plus the second was x to the 5th plus 7x times the derivative of the first, which is now going to be x squared will be 2x plus 4 is plus 0. It's going to go away. So this is my second times the derivative of the first. And in reality, that's pretty much my answer. You can choose if you need to clean this up and FOIL it all out and distribute and get a cleaner answer. Or maybe you don't need to. Maybe there's no purpose and you can leave it alone. I could multiply, since this is a 0, I could cancel that out. And I could multiply my 2x in pretty easily. I don't even feel like foiling all this, so I'm just going to leave it. X squared plus 4 times 5x to the 4th plus 7 plus, multiply the 2 in here, I'm going to have 2x to the 6 plus 2 times 7 is 14x squared. I'm going to leave it like this. If you want to FOIL it out and clean it up more, go for it, but it's a good answer. So that's our product rule. It's when you're multiplying two things and you have to kind of go through those steps. So let's look at the quotient rule. New example. All right. So the quotient rule is for problems like this. I have y equals a fraction, and then in this fraction I have 2x plus 5 over x squared plus 1. We already did a fraction problem in this video earlier. It was the first example that we did. I'm going to go back and put it on the screen here for a minute. This example that we did at the start of the video was a fraction. And remember what I did? I just made it a negative power and then did the power rule. That's not going to work on this problem because it's not just one thing down in the denominator. It's x squared plus 1. You're not going to bring both of those up with negative powers. So instead, we go for something else. We say, okay, if that's not going to work, let's use the quotient rule. I don't know where my red pen went. Okay, so quotient rule. And the quotient rule is a lot like the product rule, but there's not a first and a second. Instead, there's a bottom and a top. So we're looking at top and bottom versus looking at like first and second. So what I'm going to do is I'm going to take the bottom times the derivative of the top. I'm going to minus the top times the derivative of the bottom, all over the bottom squared. So those are the steps I'm going to go through. So let's find the derivative. I'm going to call it dy dx this time, just to practice another notation. And the derivative of y is going to be the bottom, x squared plus 1, times the derivative of the top. The derivative of the top, if I power rule it, is just going to be 2 plus 0. So I'm going to just say 2. Minus the top, 2x plus 5, times the derivative of the bottom. The bottom, if I power rule it, is going to be 2x plus 0. So I'll just say 2x. All over the bottom squared. X squared plus 1, quantity squared. That's my quotient rule. So we've got bottom times the derivative of the top. So I'm going to write deriv top minus the top times the derivative of the bottom. Deriv bottom. All over the bottom squared. That's my formula. And we can clean it up as much as we want, or sometimes we can just walk away from it and not mess with it. That's really up to choice. A lot of times we try and clean up the top of the fraction, but don't bother doing anything with the bottom. So dy dx is going to equal, I'm going to go through this a little bit. The top I'm going to multiply the 2 in, so I'm going to have 2x squared plus 2 minus parenthesis, and then multiply the 2x in. So 2 times 2 is 4x squared. 2 times 5 is 10x. All over the bottom squared. X squared plus 1 squared. And then if you want to keep going, take the negative sign, distribute it in, and combine some things. So 2x squared minus 4x squared is negative 2x squared plus 2 minus 10x. All over x squared plus 1, quantity squared. That's my answer. So dy dx, the derivative of y, equals that whole thing. So we got power rule, product rule, and quotient rule. And if you can get the 3 of those down, the rest of the school year is going to go easier for you, to be honest. So memorize that product rule and quotient rule. Get stuck in your head. It'll help you in the long run. Hopefully that helps.